And in section 1, it's describing the chemical reactions. And this was a major part of this section because everything we had to do was about balancing equations, and after we did a lab, we'd always have to figure out or make up a chemical reaction and write it out, or a theory. So in this section, we learned to represent a chemical reaction by using a chemical equation, which is what we used after every lab, was the equation. So it's set up reactants are on the left, and what it ends up, or your products, or what it turns into, is on the right. So you start out with your reactions and everything that's going into this equation, and then the arrow yields to what your equation actually turns out to be. So for example, we have iron plus oxygen, which will lead to iron 3 turning into oxide. To write a word equation, you write the names of the reactants to the left of the arrow, which are the reactants, and then you separate it by the sign like we said, and then that leads to the products of the right. So for an example, say a chemical change would occur, for example, when bread is being baked. You have the flour, the salt, the yeast, and water, and they are all ingredients for making this bread. And your reactants and the ingredients undergo chemical changes to form the product, which is bread. So you could easily make up a chemical equation for making bread, and that kind of relates to our real life situations for baking. And there are certain rules you have to apply when writing and balancing chemical equations. Number 1, you have to find correct formulas for reactants and products. So you have to know what kind of, letters and numbers you're putting in to put your formula. Number 2, you have to write the skeleton equation. Number 3, find the number of atoms in each element in reactants and products. 4, balance the elements one at a time to equal amount. 5, check each atom to make sure it's equal, otherwise it won't turn out right. And 6, make sure coefficients are in the lowest ratio term. If we move on to 11.2, that is discussing the types of chemical reactions. So this kind of just makes it more clear and classifies what certain reactions are. And in this chapter, there are 5 major types that we'll learn about. But we learned that if you recognize a reaction as being a certain type, then it's easier to predict the products of the reaction. So in our labs, when we would recognize what it is, it'd be easier for us to tell out what the equation would end up being and how the lab would turn out. So my 5 major types of reactions are combination, decomposition, single replacement, double replacement, and combustion, which we did a whole worksheet about and had to fill out and describe everything. And so a prediction would be the number of elements and compounds reacting would be an indicator of the reaction type and possible products put into that. And then going to the last section, 11-3, which is the reactions in the aqueous solution, which we didn't really cover too much. But in this section, we learned to predict formation of precipitates and write certain equations to describe the reactions that produce them. So I guess we kind of did this like a precipitate of silver chloride formula when an aqueous solution of silver nitrate and sodium chloride are mixed. That's kind of an example of how it would turn out and what that's like. And for example, a net ionic equation shows only those particles involved in the reactions, and it is only balanced with respect to both the mass and the charge. And you can predict the formation of precipitate by using a general rule for solubility of ionic compounds. So that's kind of everything that we learned in this chapter 11. Very compacted chapter, kind of short, but we learned a lot about balancing equations and writing chemical equations. So those are the main points in that.